Hello and welcome to part 20 of the mod making series for locked loot containers. Um, in this one, I was working for many hours today, just trying to contemplate as well as actually practically code whatever, like put in the stuff that I was contemplating and stuff, and just kind of messing around and everything. Um, and it's for me, it's pretty late right now, like later than I normally would record this. But yeah, so it's gonna be a relatively quick one that I'm just gonna try and explain what I did over those kind of hours to some extent and what I was trying to do. So yeah, here we go, I guess. So it was kind of a bunch of stuff, but what I have been trying to do today was basically in my mind, I was contemplating the thing I wanted to do with the quote unquote the context, the context sensitive sort of stuff or whatever you want to say, the evaluating the context of where a chest is and the room that it is in or what kind of situation it's in, what kind of environment it's in, like mostly in this case stuff like if a chest or if a loot pile in this case, since a loot pile is being replaced by a chest potentially, um the like if the loot pile is inside of a closet, just a closet with a closed door, um or if that loot pile is inside of a big giant room, big open giant room, or if it's inside of a room that has a bunch of furniture in it and other things like beds and a camp or whatever, a fireplace and a bed, uh, dressers, whatever, like all that stuff. Doors, especially doors, possibly how much space is in the room in general, like open space, how big the room is, whatever. All these things I want to be able to, on the fly, whatever you say, when the loot pile is being selected or checked, um, I want these things to be considered and then use that to modify or change the odds of that thing being turned into a chest or being, yeah, being having a chest replace that loot pile, or at the very least have the properties of that chest being generated there be modified or somewhat determined by that context. So, like, I would kind of rather it be in those, depending on, like I said, depending on the context, of course, um, in those big giant rooms that it's just like open to the, completely big giant rooms that are just open to everything. I personally would think that depending on depending on the kind of room, I don't think that somebody would probably put a chest in one of those kind of things. Like, maybe in some cases, but to me at least, it seems a little bit weird that you'd have like a chest in there, or at the very least, maybe not a very um rare one, wherever you want to say, not a very well protected one or whatever. I just kind of think that that would be more the loose loot pile sort of deal more than a chest. But in places like somebody's room or a bedroom or a royal quarters or inside of a actual, like treasure room, a proper treasure room or a closet or something like that, I would want in those kind of environments probably a much higher probability of a chest being created there, being generated there over the big giant open rooms. Because I'm like, well, somebody would probably keep their valuables to some extent inside of their room, their quarters, where they keep their stuff, where they stay generally, where there would be that would be considered their like little cut of whatever that location is. That would be their little private area sort of thing. So that's where I would think that people would probably keep their belongings and valuables to some extent, and they would probably want to protect those with decent chests or something like that, decent containers. So in those kind of contexts, I would want the chest to be higher chances of being a chest, as well as chests that are possibly of better quality and stuff like that, higher value. And that's the idea that am trying to go for here, is that I want some way to be able to detect or evaluate, like automatically to some extent, as much as possible here, automate the evaluation of the value or whatever the context of these rooms. So the way that I was thinking of doing that was, at least the best way I was thinking of doing it that I could think of, was to, since we have the position of the loot pile, we're evaluating we're evaluating the context of it around it. Since we have that position, let's just make a check based on a shape, whatever you want to say, on the shape of the room around it, and any objects within that space would be evaluated and taken into account for this kind of context related evaluation of the room itself, which essentially boils down to what I'm trying to do, at least, is to determine the general size of the room, at least, firing six rays inside of this, firing 6 rays from this loot pile in question, or each one, I don't know, however we're gonna do it exactly, but firing 6 rays from each one, from the above it, below it, to the left of it, to the right of it, to the front of it, and the back of it. So like 6 directions, making like kind of a cube shape almost. And then whatever these 6 rays happen to hit along the way, that being a collider of some sense, hopefully that's like a wall or any kind of collider, like a wall. Mostly want to be like walls, a door, whatever, an obstructive thing. We want that ray to then return back how much distance it traveled, so then we can know generally how big the room is around that loot pile, that object we're evaluating for. And then with that, those 6 different distances around the object, we can hopefully try to create a cubic area or a rectangle kind of area around that, and determine like approximately the size of the room that thing is in. And that is essentially what I've been trying to do all of today, because I've never done something like that. I haven't done any testing for this at all yet, but I mean, it's looking like it should work, at least in theory, the way I'm trying to do it. But what I've done so far, I guess I'll try to explain it, is I've just kind of copy and pasted a whole crap ton of stuff. The primary thing coming from, well, my own code so far, just kind of copy and pasting stuff for the functioning of it and stuff. But then a lot of it coming from this Daggerfall missile method, area of effect, which doesn't do a box overlap, whatever you want to call it. Doesn't do an overlap of box, and it doesn't do a box overlap to check for all of the things that are within it and touch it or whatever, this shape. It uses the sphere, and that's how it determines what is in the AoE of the missile that has the the AoE effect. Either the missile or the person that it originate that it the AoE that it is originating from, that being either the player or whatever caster is using an AoE spell. It makes a sphere, and then whatever is touches that sphere or is within that sphere, that being overlapping that sphere, uh entities like enemies and stuff like that, that is what determine that is what it puts those in a list, and then loops through them, enumerates through them, and then gives all of those the proper role and stuff like that for being affected by that spell itself. Um, and that's essentially what we're doing in a similar sense, is that we're trying to check whatever objects overlap within this box that we're making, and then instead of in this case taking the entity behavior, we're going to try and determine like what those things are. Like, is that a bed? Is that some kind of other furniture model? Is it maybe some other things that would be like, I would think wouldn't be a place that you probably keep valuables or something like that, such as those like rooms that are full of the torture devices and stuff like that, the fucked up um torture device benches and stuff. Like, that wouldn't be a room that somebody would sleep in. That would be, or keep their valuables in. That might be a room where they'll keep like a wooden chest to keep tools and apparatus and stuff for fucked up torture and everything. So those kind of rooms, I'd be like, okay, so that would, these torture devices, these models, if we find them within the list that have overlapping, and then we can assume that we're probably, this loot pile's in that kind of room. So we would probably take away from the value of the room to change the odds of chests being generated in there, as well as the rarity of the chest, whatever the value of the chest. Whereas stuff like beds, bunk beds, cabinets, maybe other chest models, the ones that don't actually get used, benches, chairs, tables, stuff like that would probably add to the value of the room, the estimated value of the room, and then we would use that, as I said, to modify the chances of chests being generated in there, what their rarity would be and such. And that's essentially what what I'm trying to do with this this box overlap thing. In the same way, it's just the more complicated thing here is that, unlike with the missile AoE thing, is that it's using a static, what do you call it? Where is it? It's using a static radius value, that every explosion radius or whatever, every AoE spell radius is the same, and that being this 2. It was, when you go up there, it's like 2.4, actually. It's not 2.5, but it's 4. So it's using a static radius. So that makes it simple enough to determine, what size you want it to be, obviously. But it's a little bit more complicated with what I'm trying to do, because I'm trying to evaluate just the room itself, but these rooms obviously change in size dramatically between each other. So I have to dynamically determine the size of this box, of this room, or try to, as best as I can, estimate the size of this room, as well as the other stuff that we're doing, not just the overlapping part. So that is what I'm doing at the beginning of this, what I did at least, is that I'm getting, just like we had before, I'm getting a list of all the loot piles within the scene, within the dungeon in this case, and then I'm looping through all of them, and then only taking the ones that have the random treasure loot container type. And then with that, I'm getting the transform for the loot pile that we're looping through, and looping through all of them. Getting the transform for that particular loot pile, and as well as the vector 3, or the position of that loot pile. And then I'm defining or instantiating, whatever you want to say. I'm populating some arrays, list, whatever you want to call them. And in this case, I make a array of rays. And in this array, I have the six rays that I was defining, the up, down, left, right, or the up, down, right, left, forward, and backward, or up, down, left, right, front, and back. Up, down, left, right, front, and back. Yeah. Which I am just, for each one, I'm just doing new ray, which is just making a new value for that, whatever, a new ray type, which is a Unity physics object thing. I'm using position of the loot pile, in this case, the POS, as the position for the ray where it originates from. And then I'm using the direction as a function of the Unity physics again, or I'm sorry, of the Unity of transforms in Unity, which are up, right, and forward, which are like I'll have to see when you get in the editor, but it's like the three arrows that each object has coming from it. Those are the blue one, the green one, and the red one. Those are either up, right, or forward, basically. And you'd think, well, that's only three directions. Well, simply enough, you could do the opposite for each one by just making it negative. So for up, I'm doing up, which is the positive version of up or whatever. And then for down, I'm just doing up again, but I'm setting it to negative value. Same thing for right. I'm getting left by setting it negative. Same thing for forward or front. I'm getting the backward by setting that negative. And I'm just making an array of that to make it a little bit more cleaner than having six separate variables. So that's what I did there. And then I make another array where I'm calling it ray distances, just so I can have a place to collect all of the distances that I will get for these rays, or how much distance the ray traveled before it hit something. That's the six values I'm collecting here with ray distances. And then box dimensions is three values, which I will be using later to give me the three dimensions of the box, basically, which in this case I'm turning later into a vector, which is going to be used as the dimensions of the box. But yeah, that's why I have this box dimensions, because then I'm just doing some math on that later, which I'm just taking the up and down, I guess one would say the sum. Yeah, I'm taking the sum of the up and down, the opposites, whatever. In this case, up, down. Taking the sum of those distances that they traveled and then dividing that by 2. I'm halving it. Yeah, I guess that'd be the average. Yeah, I guess I'm taking the average of those opposites and then using that as the final value of the dimension for the box, I guess. So yeah, up, down, left, right, left, front, and back. But then before that, I even do that part, I'm doing this loop here, this for loop, where I'm basically just having it do the actual ray casting part, using the rays from that array that I made before, and then sending them a maximum of 50 distance. I mean, I don't know what I'm going to set that to later, but right now I'm just setting it to 50. And then taking that, if it hits something, taking that hit distance and then giving it to the ray distances array that I have. And if it doesn't hit anything before it travels 50, then I'm setting it to just 50. That'd be the maximum distance or whatever. But then when all of that is looped through, and we have gotten all the ray distances for these ray directions, Then, like I said, I'm doing the math, the averaging out for the two each to get the three directions, or the three, like, dimensions, whatever you want to call it. And then I'm defining a vector 3, the box dim vector, and then I'm just putting those values, the box dimension values in that to make that vector 3, which will then be used later. One thing to note with loops, at least the way I'm doing it, there's probably much different ways, much cleaner, better ways to do this, but I just kind of like using for loops. They make sense to me. They make sense to me, so that's why I kind of use them often instead of maybe some other kind of loops and stuff like while and other things like maybe enumerate and stuff like that. So generally, I just kind of use for loops where it makes sense to me. But in this case, I have a for loop within a for loop. And then even later, I have another for loop. So I have two for loops within another for loop. So when you do that, make sure that your number that's being enumerated, such as this one, the main loop, make sure that I is completely separate, or the enumerated values, from the other for loops enumerated values. Like in this case, instead of I, for the second one within, I'm using H. And then for the third one, I'm using R instead of I or H. Because even though I'm sure you can do stuff like that, I've done it before where I've mistakenly put in like an I instead of where a J should be or something like that. And then I have it where I accidentally cause an infinite loop, and then I've literally had my like Unity editor crash because of the infinite loop, or I've even had sometimes where my computer crashes because I have an infinite because I had an infinite loop and the computer just blue screens. So yeah, I've done that before. So be careful when you're doing loops. Make sure that your enumerated values have some point where it actually ends when you want it to, and you don't have that situation where you have an infinite loop accidentally and then stuff like that happens. Yeah, you want to try and prevent that. But anyway, but after all that stuff, we got the vector 3 dimensions of the box, of the box. We are now doing the actual, or trying to do the actual collecting of the objects that are in the overlap of the box. So collect game objects that overlap the box and ignore duplicates. Use this later to estimate a room value that a chest is being generated in. So we're making a list here, or instantiating a list here called room objects, which is then going to be the collection of game objects or whatever, like things that have been overlapped that we will then use to loop through that eventually and then try to estimate the value of the room based on those different objects and such. The sum of all those objects and everything and other things like that. So with that, we have this is basically, so much of this was just copy and pasted from that missiles here, the do area of effect sort of thing. But in this case, we're collecting a array of colliders we're calling it overlaps, which we are then doing a physics.overlap box. I guess it would be like a cast, whatever you want to call it, like physics overlap box. And we're giving it the position, the original position of the loot pile we're evaluating for. And then the thing that we made, the box dimensions dim vector, we're giving it that, which is the presumably the dimensions of the box that are going to be cast here, the size of it. And the rotation here, we don't even need this technically, but I wanted to make sure that only player layer mask, that layer, was being evaluated for or being checked, because I don't want stuff from the auto map, which is a different layer, to be evaluated. And like, yeah, I don't want that. So I wanted this to specify only the player layer mask to be evaluated for, and to ignore the other stuff. So I had to give this thing the quadrillion, or what the hell is it called? The Quartinian or whatever, the Quartinian, the rotation. I just gave it the same rotation that the loot pile has, which in the end I might have to change it to something else, but I don't know. We'll have to see. But that's how I gave that. And then I'm doing this third for loop here, where I'm basically going through the overlaps that we got, and then finding the game objects for the overlapped objects, and then determining which ones we care about and which ones we don't. So first we're getting the game object, or trying to get the game object for whatever the overlap is, that we're looping through and everything. And then after that, we're saying, make sure that the game object exists first before we evaluate this. Otherwise we would possibly get an error. So that's why we make sure game object go. And after that, if that is true, if this is not null, then game object equals loot piles, the loot pile that we're going through, dot game object. Basically saying, make sure that whatever loot pile we're evaluating for, ignore that game object, because we don't want to use that. We don't want to evaluate for the thing we're evaluating for. We don't want that to be taken into account for this context thing. At least I don't. So we're filtering that out. So whenever it finds that one, just continue with the loop and don't do anything else with it. But then after that, we are making sure that any game objects within the room, or any game objects that are being overlapped here, any of them that have already been added to this room objects list, if it finds any of them in there, like if it finds any of them in there, then it won't continue down here and it won't be added to the list again. So this is here to prevent duplication or duplicates of evaluated game objects within the overlaps that were overlapped. That's all it's doing, basically, is trying to prevent duplicates from happening, from being added to the list. And that's why it's the exclamation point here that's not. So it's saying like room objects, if room objects dot contains game object, if that is no, then it'll be like, okay, so they didn't find any in there already, so then you can add it to this list. But if this was true, if it did find one within that list, then it would be like, all right, so don't do this, so don't add it to the list, and do whatever afterwards. So that's there to prevent duplicates, and outside of that, that is as far as I've gotten today on this. And tomorrow I plan on continuing working on this part specifically, and then possibly maybe even doing some testing for it to make sure that it actually might work the way I'm thinking of. I'm sure there's going to be so many problems with it, but this is the best I have for right now. And tomorrow I plan on working on it more, and I will hopefully give you some more details about that when I get to it. But for now, that is all for today. So I hope you enjoyed somehow, and I will see you in the next one.